All right. Hello, wonderful people. Let's get started. So, what we're working on today, write expressions in radical form, and we're going to use the square root property to solve quadratic functions. So what you need to know. So in review, so this is stuff that you might have covered in Algebra 1, and that is how to work with radicals. And a radical is any expression that has a square root or a cube root or anything like that, any other power or index of roots. The radical symbol kind of looks like this division bar, although it's not really a division bar. It's actually, well, if you think of like multiplication as being an exponent, then a radical is kind of like the division part of that. It's like division, but of powers. So anything that is underneath the radical symbol is called the radicand. And what you need to know also will be the first 20 perfect square numbers. A perfect square number is a number that you can multiply by getting that same number. So you multiply two of the same number to get that number. Like, for instance, 1 times 1. 2 times 2 makes 4. 3 times 3 makes 9. 4 times 4 is 16. 5 times 5, 6 times 6, and so on. So it's a good thing to have all of these numbers listed because we're going to need to use them for simplifying square roots or simplifying radicals. So we got 400, which is 20 times 20. So if you use this, you'll be able to find them a little bit easier. All right, and let's go ahead and take the two possible cases for simplifying radicals. Case number 1 is that you get a perfect square number. In that case, you would just take the square root of the number underneath the radical, the radicand. But what if it is not a perfect square root or a perfect square number? What we need to do is we need to break the radical down into factors and try to get one of those to be the largest perfect square number that we can get. So sometimes it might take a little bit of working with some of the numbers. You might also get some numbers that are that you might need to try again with. So be careful with that. And then after that, you take the square root of the perfect square and leave the leftover under the radical symbol. So sometimes you just can't take everything, all right? Sometimes you just got to leave a few things behind. So in both cases, if you have a coefficient that is a number outside the radical, multiply this with any number that you take out. So if I have, say, 2 times the square root of 9, all right, so we can take the square root of 9. If I take the square root of 9, I get 3. Now, when you factor it out, you're going to get, okay, so 3 times 1 is one way you can get, 9 times 1. So basically, you leave a 1 here, but the square root of 1 is 1. So 3 times 1 does not change anything because of identity property. So I just multiply 3 times the number that was already outside, which is 2. So 2 times 3 is 6, and that's going to be the final answer for this one. And that's pretty much all you need to know for this lesson. Let's go ahead and get started with some of the exercises. All right, so what we're doing with these is we want to write all of these in simplest radical form. So remember, on the first case, we had some of them that were perfect square numbers already. In this case, you may recognize 49 as a perfect square number. And it is a perfect square number because of 7 times 7 is 49. So I'm going to break 49 down into 2 numbers. Now, you don't need to do this every single time. If you know what the square root of 49 is, go ahead and just put that down. But what you're actually doing is there is an index here, which this is not part of the lesson here because we're only working with square roots. But if you see a basic radical symbol with no other numbers on the outside, and they're usually little numbers in the front, that's called the index. So in this case, it's telling me that I need two of the same numbers to get out of the radical. Since I have two 7s, they come out of the radical as one number. So it's kind of like a carnival ride. I kind of explained that to be like a carnival ride. Like for instance, here I have two people in line. All right, I have 225, which is 15 times 15, right? And it says here, this sign says I need two people to get on every single cart. Carnivals do this for a number of reasons. One, they want to keep the rides balanced, and they want to keep the line moving as fast as possible. But when it comes out, there is only one number 15. You can also think of the radical as anything in there is half as powerful as its number that it's depicting. And when I say half is powerful, it's not like, it is kind of like division, but like I said earlier, if you have exponents are a form of multiplication, then square roots are a form of division in a way, although you're not technically dividing. All right, and here's where we have that very bottom case where we have a number on the outside of the radical. So if I ask you, what two numbers can I multiply to get 144? You would probably tell me without missing a beat, it would be 12 times 12. Now you don't need to do this every single time. In fact, you know, maybe I might stop this or kind of switch between different methods, but pick a method that you like, that you're comfortable with, and stick with it. So 2 times 12, actually, when I take it out of the square root, there's only going to be one of them. So it's 2 times 12, which in this case, 2 times 12 is going to be 24. And that's our final answer. All right, so one thing we have not covered yet is what do we do if it is a fraction? So 4/9 is a fraction. So when you're using distributive property on a group, this radical is like a grouping symbol, right? So just like with distributive property, that means you have to do to both of them. So I want to give each one of them their own group. So root 4 and root 9, and if you have something like this, take the root of each number as best you can. So since 4 is already a square number, I can take the square root of it pretty easily. 9 is also a square number. So now my answer is 2/3. Okay. Nicely done. Moving on. And it looks like we have the same thing here. I have a fraction, so I'm going to take the root of both numbers in the fraction, our numerator and denominator. That's what they're called, the number on top, number on bottom. But that's okay. We don't really need to know that too much right now. But what two numbers can I multiply to get 1? Now don't forget, 1 is actually a square number because 1 times 1 equals 1. So 1 here, and 89. What am I thinking? 81. Okay, never mind, that doesn't look any better. 81. And let's go ahead and take the square root of 81, which is 9. And we have all the radicals gone, and we can't really do much else. So that is going to be the answer for that. Okay, moving on to the next one. Now, if you're feeling pretty good, you can kind of skip that middle step of having to take the root of 36, because you may already know what the root of 36 is. It would be 6, and the square root of 121 is 11. Because 11 times 11 is 121. Or again, if you have that list of perfect square numbers, then it becomes a little bit easier. But I want to show you a trick probably on the next slide on how you can use a calculator to find out easily square numbers. But in the meanwhile, it looks like we are done with this slide. And off to the next one. So here we have 112. 112 is not a square number. We know that 10 times 10 is 100, and 11 times 11 is 121, and 112 is directly between 100 and 121. So this is not going to be a square number. So we're going to have to find a way to make it into a square number. I'm going to go ahead and switch over to another screen. I'm not too sure how well you can see this. So 112 divided by 2. And we get 56, which neither 2 or 56 are square numbers. So let's go ahead and divide it by 4, and we get 28. Now we could take the square root of 4, but let's see if we can get a bigger number. 112 divided by 9, and that's not going to be a whole number, so it only works if this is a whole number. So let's go ahead and divide it by the next square number that we can think of, which is 16. Which in this case, 16 times 7 is 112. So let's go ahead and make 16 our larger number. So break it down into 16 times 7. And a lot of teachers will show it this way, where it's root 16 times root 7, but some of them will also show it like this, which is how I did it for the longest time. And in either way, you just take the square root of any number underneath the radicals. So if I take the square root of 16, that'd be 4, and 7 has to stay in the radical because it's not a square, and there's nothing we can do to get it out. It just sort of gets left there. And in this one here, we would also just take the square root of 16, which goes outside as 4, leaving 7 on the inside. But I'm going to go with this method here. I think is a little bit newer. I think that's the more modern method of doing it, I guess. And let's move on to the next one, number 8. For number 8, we have the square root of 245. Right, there's a bit of a problem, and that is 245 is not a square number. So what can we do to fix that? Well, let's go ahead and go back to the calculator and find something that we can divide it by. So let's start off with our number 245. Oopsie, 245 divided by, I don't think it's going to divide by 2 or 4. It might divide by 5, but that may or may not help. Oh, never mind. It helped. We got it. Sometimes you can just sort of luck into these, but we know that 49 is a square number, so let's go ahead and use 5 and 49. Oh, okay. 5 times 49. Now I'm going to put 49 first. Like that. And let's take the square root of 49, which is 7. So 7 becomes a whole number out front. 5, on the other hand, we can't do much with it, so it's just going to stay in the radical. All right, so I guess that's it for those two. Let's move on to number 9. And we have a number already on the outside. I have 5 on the outside. So anything I take out as a square number is going to have to be multiplied by the 5 that's already there. So if I ask most students, okay, think of two numbers that multiply to 72, they're probably going to say the same thing. They're probably going to say 9 times 8. Because it just goes back to that times table that most students have in their heads that they learn at a young age. Now this does work because you can take the square root of 9. So if I have the square root of 9 and the square root of 8, but the problem is 8 can actually be factored out again because it's made with 2 and 4. So let's go ahead and ignore 9 and 8 for now, and we got to think of a bigger number, an even bigger number that it works with. So 72 divided by, let's go, okay, so we have 1, 4, 9. I don't know, we already tried 9, it does work, but it's not a square number. Let's go with 16. Nope, 16 is not going to work. 72 divided by 25? No. Well, we know it's not going to work with 25, so let's try 36, which in this case I get 36 times 2. So that is a larger square number, so let's go with that. 36 times 2. 5 times 30, root 36, and root 2. So I can take the square root of 36. That would be 6. And all three of these numbers are being multiplied to each other anyway. So I'm going to put that times back in there. So remember, these are three numbers all being times to each other. But since these are whole numbers, well, they represent the coefficient of both of them, and they're both, we can just multiply them together. So that would be 30 times the square root of 2, or 30 root 2, like that. All right, now let's go ahead and do this one here. I need two numbers that will multiply to 45. Now, at this point, I'll get students that will say, well, what about 3 times 15? Well, 3 and 15, neither of them are square numbers. Okay, so we're going to need a bigger number to go with. So yeah, 3 and 15 won't work out. So let's try, let's try 9 times 5. 9 times 5 is another combination of numbers that can multiply to 45. And in this case, 9 is a square number, so let's go ahead and take the square root of 9. Oopsie, I said take the square root of 9. Yeah, there we go. So now I get 9 times 3, which is 27 root 5. And it looks like that's as simple as we can get it. All right. Now this one might be another kind of easy one, because if I ask most students, think of two numbers that multiply to 250. What are two numbers that would multiply to 250? All right, now this number ends in 0. So if something ends in 0, we know that it can be divided by 10. So let's try that out. Let's see, square root of 25 times square root of 10. And we can take the square root of 25, which is 5. And I cannot factor 10 down anymore. I can get 2 and 5, but if I did that, I would have no pairs of numbers. 2 is not a square number, 5 is not a square number. So this is as simple as we can make it. All right, number 12, last one for this page. 575, what can we do with that? So I'm gonna go ahead and go back over to the calculator. And 578. And I need two numbers that'll multiply to 578. This would be a lot easier if you had the list of perfect square numbers. We could try dividing it by 2, and that becomes 289. 2 times 289. Now, keeping 289 in mind, we can see that 289 is on the list of numbers of perfect square numbers. And we've seen some other perfect square numbers here just a minute ago, like 49 and 129, I'm sorry, 121. But anyway, there we go. So 10 times 10 is 100. 11 times 11 is 121. 12 times 12, 13, 14, 15, 16, 17. So it's going to be 17. So 3 times, oopsie, root 289 times root 2. Square root of 289 is 17. And there you go. We got it. Just about. Multiply this together. 3 times 17 is 51. And that looks like it's it for that one. Nothing else you can do. Now keep in mind that this is kind of like a, this is kind of a review of Algebra 1. I know I teach it in my Algebra 1 classes, but what do we need to know for today? So we're going to take this step we're going to take this lesson a few steps further from what we already know. So we're going to learn how to solve a quadratic by using a square root, or what we call the square root method. All right, so this only works on the quadratics in this form, so it does not work on standard form quadratic equations. In this case, we are missing a b value. See how the b value is not there? We only have a and c, and that's it. So if you notice that you're missing your b value, you can go ahead and use this. Now, when you do this, what you need to do is you need to get that x squared by itself. You'll have a number. And you're going to take the square root of both sides. Square root here, square root here. Now, I'll go ahead and wait till I show you on the next slide the first exercise, then I'll go over a little bit more about what this plus and minus sign means. So you will get two possible answers, two solutions, because remember, I don't remember which lesson it was, but I told you if you are solving an equation or you have an expression with a square or a 2 power, that oftentimes means that you will have two solutions, two answers. So the first thing we want to do is isolate the x squared as much as we can. So just like solving regular algebra problems, we want to get this x as by itself as possible. Take the square root of both sides after you do that. And then we simplify the radical. That means just do what we did on the first few exercises. And then we need to place this positive negative sign in there to indicate that we have two answers. So there are two cases. I'll show you again what this means a little bit more as we go on through the exercises. All right, so let's go ahead and move on to our first exercise. So following the directions, let's go ahead and isolate x squared as much as we can. So I'm going to do the inverse of minus 64, and I am going to add 64 to both sides. So I get x equals 64. Now, if I were to ask you, what two numbers can I multiply together to get 64? Without missing a beat, I'm sure people are going to say x equals 8. Now insert Yoda meme here. There is another. All right, there is another answer. If you've been following a lot of the work that we've been doing where we plug things into a table of parabolas, you'll notice that you also can use negative numbers to get the same result. So I could also use negative 8. Negative 8 times negative 8 is still positive 64. But we could write the answer like this, but I think we're going to practice using the symbol that they told us to, because that's what the directions say, and whatever the directions say is what we have to do. So in this case, let's use the plus and minus 8 symbol to show that our solution is positive 8 and negative 8. Now moving on to the next one. Let's isolate this just using regular algebra. What you would do in most everyday algebra problems. Okay. Now we still got to get rid of this 7, right? Because we got to get that x by itself. So I'm going to take both sides and divide them by 7. So I get x squared equals, oh, wait, 15 minus 8 is not negative 7. What am I talking about? So 7 divided by 7 is going to be 1. Now, again, we run into this problem of what number can I square to get 1? And don't forget, 1 is a square number. 1 is a square number. So if I were to take the root of both sides, and also taking the square root is how you cancel the square. So square roots and squares are inverse operations. They will undo each other. Like if I take 7 and square it, I get 49. If I take 49 and I take the root of it, I will get 7. So they undo each other. They are the inverse. But anyway, that power and the root cancel each other out. So I will end up with just what's on this side, which the square root of 1 is just 1, because again, 1 times 1 is still 1, so 1 is a square number. And I get x is equal to positive and negative 1. Now, while we're here as well, I am also going to go over to Desmos and plug these in and show you, or I should say remind you, what it means to look for a solution. So I'm going to go ahead and punch in the first one. So use my keypad down here. X squared minus 64. So this was exercise number 1 for solving the quadratic by square roots. So remember how I said it's negative 8 and positive 8? Well, there we go, negative 8 and positive 8 on the graph, and those are the x-intercepts, which we also call the zeros, or the solution. Solutions in this case, because there's 2 of them. And the solution is what you plug in to the formula to make it true. Okay. Well, while we're here, let's go ahead and do number 2 as well. Now, we have 7x squared And I have plus 8 equals 17. I'm sorry, plus, let me just go ahead and type it in the way it looks. And you notice that this does not look like a parabola. So I'm going to minus 15 from both sides. And that would be, that would be, come on, negative 7. Sorry, not negative 7, positive 7. Oh no. Hey, hold on, did I type something wrong? Because that is the way it should be. Oh, okay, I must have, something must be tripping. But anyway, there we go. So that is the right way to graph it. So I have to put everything on one side if I want to graph it. Sort of like if you're going to factor it, you're still going to have to put everything on one side. Anyway, we have -1 and +1 as our solutions on the graph. So +1 and -1. So again, that was just a quick refresher to remind you that these are things that kind of relate to each other. So if you can understand that how they relate to each other, it becomes a lot easier to work with them. Or it gives you alternative methods to solving them or checking your answers. Okay, let's go ahead and work with this one here. So I have -5 to isolate our number, 81x squared. 21 minus 5 is 16. And I still need to get that x squared by itself. So isolate by dividing both sides by 81. So again, we're just kind of working backwards with all of our inverse operations. And take the root of both sides. So take the square root because we want to undo. We're getting rid of that 2 power. And I'm going to kind of use the shortcut here. Take the square root of 16 and take the square root of 81. And we are done with this one. All right, moving on to the next set. So now we got to know, what can I plug in for x here that if I square it, times it by 8, and then add 1 to it, will give me 17. All right, so that's quite a lot of stuff. So let's start working backwards. So if I minus 1 from both sides, 8x squared equals 17 minus 1. So 17 minus 1 is going to be 16. Now, that's 8 times x. So to do the inverse, I would have to divide both sides by 8. So I get x squared equals 16 over 8, which is 2. And I'm going to go ahead and take the square root of both sides. Now, undoing this, again, you got to also remember that there is a positive and negative solution. And I cannot break down square root of 2 anymore, so I'm going to have to just leave it as square root of 2. So if you can't take everything out, sometimes you will be left with a radical expression or numbers under the radical. So that's about as far as we can go with that one. Ouch. All right, I'm going to go ahead and start solving this one. Let's get that 9 out of there. So 9 plus 55 is 64. And I got to get that 2 out of here. So let's go ahead and I'm going to divide both sides by 2. X squared equals 32. Now at this point, I am going to have to take the root of both numbers. And I'm going to show you another way. You could do what we were doing earlier and look for factors with a square number. Okay, and in this case, it would be 2 times 16, which is pretty easy. And again, if you want to stay with that method, go ahead. But I'm going to just show you another one because I know sometimes I do get people who have trouble with breaking down numbers. So if you don't want to do all that looking for certain numbers, what you can do is completely factor the number. So if I want to completely factor 32, let's start off with taking out the smallest factor. So that's 2 times 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 times 2. Okay, I'm getting really, really small here. So that's 1, 2, 3, 4, 5 2's. Break them into pairs, 1 and 2. Now, if I put these together, I get the square root of 4, which is 2. Square root of 4 is 2. 2 times 2 is 4. But there's one left over down here. That one has to stay in the group because it doesn't have a pair. So when you're taking square roots, there's a little number here that I called, or that is called the index. I don't call it that. Everyone calls it that. Think of it like a carnival ride again. So in this carnival ride, they want everybody to get on in 2s. So I fill one cart and I fill another cart. This guy's going to have to wait in line because, well, he's going to have to wait for another single rider to jump on with him. And there we go. That is the final answer for that one. Number 6. Okay. Oopsie. Let's go ahead and start working on this one. So minus 3 to both sides. 9x squared equals 108. And I got to get rid of that 9 as well. So I'm going to divide both sides by 9. And I think this is going to be 12. Let me check my multiplication table on the wall. Yep, going to be 12. Now take the root of both sides, square root both sides. And 12 is not a perfect square number, so that means I'm going to have to do a little bit of work with it. Now, in this case here, this one might be another easy one because if I said think of two numbers with 12 and one of them being a square number, you might say 4 and 3, which is true. 4 is a square number, but I'm just going to break this number down all the way. And look for the pairs. If you have a pair of numbers, it can come out. So 2 comes out and 3 stays in because 3 is by itself. There's only one of it, not a pair. So it stays in there. And looks like we're done with this one again. Moving on. Okay. Write each expression below in simplest radical form. So same thing. Actually, if you look in the packet, it's all on the same page, so oh well. Actually, you know what? I haven't been writing those things anyway. Looks like we're going to have a negative here. We better get rid of this negative before we start doing too many other things, and this is going to be 77 and 4. They're both negative, so it's going to be like adding them, so it's going to be negative 81. Divide both sides by negative 3. And I get x squared, which is now isolated. And it looks like we're going to get 27 because negative cancels the negative. 81 divided by 3 is 27. Now I'm going to take the root of both sides. And that root is going to undo the power. So that's going to leave us with just x. And now I have 27. So in this case, 27. If I were to break it down, I would break it down into 3 and 9. 3 and 9 break down. But you know, 9 is also a square number. So I can take the square root of 9. So square root of 9, square root of 3. Because don't forget, this is the square root of 27. 3 root 3. Now again, don't forget the plus and minus sign. Because this is not just one solution. There are two solutions. They are both the same absolute value, meaning it's the same number, but it's not the same sign. One is positive, the other is negative. So don't forget that plus and minus symbol. Because we need to have everyone know that there are two solutions to this. Okay. Now for this one here, I'm going to minus 10. And again, you just start with these like you would any other algebra problem. Just ignore the square for now, okay? We'll save that square to the last step. So 5x squared equals 300. All right, now I got to divide both sides by 5 because I got to get that x as by itself as I can. Cancel the 5. X squared equals, now what is 300 divided by 5? All right, so here's what I'm going to do. I'm going to ignore this last 0. Just pretend like it's not there. 30 divided by 5. Okay, you might know it's 6. Now bring back that 0, so it would be 60. And that's how you can divide any number that ends in 0, or any number that's divisible by 10. Root both sides. And square root of 60. So I can't do this one. Now I'm going to have to break down 60 into some numbers. Now in this case, I'm going to go back to doing it the other way. I'm going to think of square numbers. So I can think of 4 times 15. Oh, I guess that's it, because 15 is only 3 and 5, which there are no square numbers in that. So let's go ahead and take the square root of 4 and the square root of 15. Square root of 4 is 2, and again, don't forget the plus and minus. And draw our box as best we can. Nice. Nice. All right. On to the final one. All right, now we have a fraction, but we'll get there when we get there. All right, now how do we get rid of this half? Now remember, a number times half, let's go back to the calculator really quick. So what is 20 times half? It's 10. Now, when you times something by half, you are essentially dividing it by 2. So we do the opposite of divide by 2. Opposite of divide by 2 is multiply by 2. Now, since I got to get rid of this negative, I'm going to multiply both sides by -2. And negative, negative cancels it out. It'll become positive. 2 times half. So if you have 2 half dollars, you will have 1 full dollar. So that's going to cancel that out. Negative times negative is positive. 40 times 2 is 80. But we are going to need to take the square root of both sides. So square root of x square is just x. And I end up with 80 again. Well, not really again, but I'm in the same process of trying to simplify it. Now I'm going to do, now with these, both of these last two, I just ended up using the method of looking for square numbers. But I'm gonna really do this one all the way, factor it all the way. 2 times 40 makes 80. 40 is made with 2 times 20. 20 is 2 times 10, and 10 is 2 and 5. Look for your sets of numbers. So that's 2, a pair of 2's, and a second pair of 2's. So remember, this is basically root 4 times root 4 times root 5. Take the square root of 4, you get 2. Square root of 4 here is also 2. 2 times 2 is 4 root 5. And again, 5, we can't take it out because it's not a number that we can really work with all that much. And it looks like we have completed this lesson. All the exercises are done. There's not really much else going on. So I'm going to go ahead and go back to the other screen. Well, that's it for today. Let me know if you have any questions. I'll be around for a bit. And if there are no other questions, then I will see you next time. Bye-bye.